Morning everyone, welcome to this session number 377, and today I will check the answer of this problem. I am tired of this, um, but curiously I submit again exactly the same answer, and now leetcode accept my result. Mm, I'm not sure why, because it's exactly the same code. Basically, it's exactly. The only thing that I removed was this, but even what is this? Where I remove the element for avoid the itself element appear this, but only that, yeah. And I'm not sure why right now. I why I got success or yeah, success submit with this exactly code. But well, I think that is strange. Now I would like to check what is the right result or answer. Yeah, and for this, one moment, please. Okay, now uh-huh. I want to check the answer. BTS with bus stop as a note. I think that this is not optimal because you are using the stops and not the buses itself. Yeah, this is basically is validate all the connection, but I think that is expensive. I'm not sure why in my case it's not, because um, my time was very horrible, and I am using the roots as a nodes. Like this, and this is the answer. And mhm, is this okay? Let me check what is happening here. Okay, nice. Now in this case, oof, too many methods. Number of bus destination. Okay, did receive the notes. I will take this as a example. Okay, now number stop receive the roots, the target, and the source and the target. Now the first is validate if the source and target are the same. You don't need take any bus. Basically return 0. In other case, here the first that is iterate over this and is sort the arrays. Okay, here I'm not sure why is sort, but it's expensive because imagine that if you have many arrays all the time, you need sort, but I'm not sure why is sort here. Yeah, now the next that is adjacent list. Okay, basically it's only create for every root. I will create a list of lists. Basically it's a hash map. Yeah, even I don't know why you use the at least or this array is a release. It's a list because when you try to access, I think that is more expensive than the hash map. But well, you sort and the final you have 1 2 7 3 6 7. Okay, keeping the same order. But right now you have three lists, empty lists. Yeah, like this. Okay, now is create grab. What is create grab? Okay, receive the list. Yeah, that in this case adjacent list. the adjacent list is a list of lists. Yeah, here. Oh. Right now, all of them are empty. Okay, nice. Now is receive the roots. Roots is transversal. The roots in this case is this. And we take the first root, that is this, and we have another that is basically with the next. Yeah, this and this, for example. Even let me copy this point, and this is the next. 3, 6, 7. And now is asked the roots in the index I. This and this have a common node. What is this function? Return true if provide roots have a common stop, false otherwise. Okay, and here receive this and this. Okay. Okay, now you have 1, 2, 3, 7, 3, 6, 7. It's equal 0. Initializing 0, and now is if this is minor that this root and this is minor. Basically it's transversal both. And roots in the index I, it's equal, in the moment that appear this, basically is stopped. In other case, if roots it's minor. Okay, I got it. Basically here, one essential here is, for the reason this algorithm, this solution uses sort, because for example, even I can use the same 1, 2, 1, 1, 2, 7, and the other is 3, 4, 3, 6, 7. Yeah, in this order. And I will start with the first, taking the 1, it's equal 3. No, means that this is not execute. And now we need to ask the 1 it's minor than 3. Yeah, in this case where this is minor than this, I need to move to the next. Yeah, because it's minor, we know that I can't search this element up before this. It's not possible because are sorted. Yeah, now the next that is 2 it's equal 3. No, 2 it's minor than 3. Yeah, means that I need move to the next. Yeah, in this case 7 it's equal 3. No, 7 it's minor than 3. No, means that now this is moved to this. Yeah. Okay, now 7 it's equal 6. No, 7 it's minor 6. No, means that I need move in this. Okay, and now is the 7 it's equal 7. Yeah. Yeah, it's essential for try to avoid too many validation. For example, in this case, I need to compare. For example, another example is like 1, 2, 3, and here is 4, 6, 7. With my approach, basically, I validate this with this, with this, this with this, with this, and with this, and this, with this, with this, and with this. You know, it's basically the how many combinations between these and these elements. 3 3 and 3, that is 9 in total. Yeah. And but here it's not in this way, because basically well, in essential, sorry, is that this it's equal 4. No, this array is sorted, means that I need to move in this direction. 2, it's equal 4. No. Okay, now it's here. 3, it's equal 4. No, don't make sense. Continue. If you only have or you only perform this function 2 times, or this comparison 2 times, and not 9. Yeah. But I think that let me remember, or let me check what is the time complexity of the sort in Java. I think that is logarithm n, but I'm not sure. Is collection, use collection right here. Where array sort, time complexity Java. I think that is logarithm n. As a Java uses logarithm n, where n is but I think that I am using Java 7. I'm not sure which Java is this. '21. Okay, I think that is log n. Okay, I will continue with this checking, and now in essential is ask this have a connection, at least one connection, and this is important. I don't need more connection, only with one. Have one connection with this, in this case 1 to 7 3, yeah, the 7. Okay, yeah, have a common, this return true. And now adjacent list in the index 0 here, this is the 0 1 and 2. I think that is only 0 and 1, yeah, because only have 2 arrays. In the index I, that is 0, add the 1, and here the positive. Yeah, basically creating a direct wrap. Yeah. Okay, now the next that is continue with the next, that is this, but don't have more element, it's not compared with anything, and it's all. Okay, right now this, the result of this, even I can only set this here. This is the current graph. Now the next that is Q, it's a BFS. Add starting nodes. What is this? What is this function? Add all the roots in the queue that have the source. Add all the roots in the queue that have the source as a one of the stops. Is existing stops. Okay. In essential, transversal all the roots for determine if the stop exists. For example, the stop exists here. What is the stop? The stop is the stop. What is the stop? The source. In which in this list appear the source. The source, for remember, is 1. 1 appear in the sorry. Here. Appear here. Yeah. Now appear here. No. Okay. Having this, Now these only have the 0. Now is set hash set. Oh, it's define the length. What is the difference with our length and with length? What is the difference between one and yeah, but what is the init with length? I I want to know what is the difference between initialize hash set with length. What is the difference? Like this. Oh, I scared the backing hash map is default capacity 6. Cause a new parameter. No, initial capacity here. Initial capacity. Construct a new empty set. The backing hash map instant has been specified initial capacity in the followed factor, which is 0.75 parameter. But I'm not sure if I have one improved in the time complexity, or why I need to use this, because in the hash map in the hash set, basically you can add, it's dynamic, you can only add the elements, but I never seen before this way to initialize the hash set. But well, in this case, initialize this. What is base? I think that is visit. Yeah, I think that is basically as a, or my intuition is more that when you use this, you don't change the size of the element of the hash set, and means that you don't need recalculate. I think, I don't know, I need to check this, but well, continue boss start in 1 is not possible 0 because the 0 has been contemplated here. Yeah, it's mandatory 1. Now is the classic BFS, get the size. Well, I think that here, while it's great that this can be changed as a 0, as a 4, sorry, is removed. return bus count. If the start is present the current route, is stop existing. Is this? Adjacent routes. Okay, I understand the question. I only have a few doubts related with my submission. What is submission? This is mine. Yeah, and in my case, I got an horrible performance. Yeah, but in this case, let me try to solve this problem. The first is, this is not necessary. In my case, I have too many hash set. I think that I can avoid this, but let me check. Okay, the first is that I validate that if the source and target are the same, in this case is 0. That's it. This is okay. Now the next that is transversal the roots and transversal every root. With this, it's only for mapping, basically. Map the root bus with the root. Yeah. And mapping if the source where appear in which roots appear the source and which root appear the target, in both. In this case, in the solution that proposed leetcode, basically transversal again all the arrays for discover this, but in this case it's not necessary because I have this, and I'm mapping the bus. Okay, I think that here I can improve this because I only need one connection between the 1 and 2, the 1 and 2, the 1 and 3, the 1 and 4. Okay. Here was stuff. This is check in which routes exist the target, and this is the same, but checking which route exists the source. And map continue. Here stop and bus. Why I am saving the stop and bus? Now the next that is for transversal stop and bus. Yeah, I think that here I'm checking the stop and the bus, this mapping. Yeah, in my site the problem was this, because this is logarithm. The time complexity is linear, and basically all the time I am adding this, and it's expensive. mm, Here I am searching. Oh, here. Uh-huh. Here, in essential is that I am connecting. Yeah, I have the stop and the bus. Yeah, and I with this I can detect, for example, if the stop, I don't know, 4 contains the bus 0, 2, and 7, means that is a connection between them. Yeah, for the reason where it's minor that this, the 2 is only ignored. In other case, I add. But in this case, why I am mapping again this? For example, this return 4, 2, 4, and 5. Okay, and I am mapping again. Mm, yeah, in here, it contains, this is constant because it's a hash set. Mm-hmm. Yeah. Okay. I think I can use the approach, but I don't like the sort for, yeah, because for have the possible connection at least one or the first, I need to sort the elements. But the problem with the sort is that it's logarithm n, and I use this all the time. Um, okay, I think that every if I had, for example, in this case, 2 roots, the root 0, the root 0, I need to detect if it's possible connect with the root 1 or with the other roots, but yeah, it's with this. With this, if it's possible connect with the others. Let me check what is the performance of the solution of the leetcode. What is this right? Let me submit for check. Oh wow. Uh, okay. Mm, yeah, it's much better. Mm, okay, I think that I can improve the solution. The first is that I validate this. Okay, I have valid this. Now the next that is sort the elements because we need to find this. But if I sort the elements, only works for stop the performance of the more comparisons, but when I try to search where appear the source in the, yeah, only the source, basically I need transversal all the arrays completely. What is the sense of the avoid? Mm, okay, I think that I can combine. The first is that for that transversal the roots, yeah, and here is erase dot sort root, yeah, I sorted, and the next is only half, only that, yeah. In this moment I have the element sorted, that is this, and now the next is find the possible connection between this and this, yeah. And for discover this, the connection is basically the double for integer root a is equal 0, root a it's minor, that roots in the position, no, dot length roots root a plus plus, and now is with the next for integer root b it's equal root a plus 1, means that the next root b it's minor, come on, it's minor that roots in the position roots yeah, have different lengths, means that this transversal, this and this and this and this, and no, it's the same. It means that this root b plus plus, because I am only transversal the elements, and now here are sorted in. I am checking the first with this, sorry, the first with the second, the first with the another, this with another, and continue. And here at this point I need to transversal the first with the current integer yeah, it's transversal this with this element, yeah. This case is integer I is equal 0, integer j is equal 0 2, and is 4 for I here. If I it's equal 0 and I it's minor, that root a dot length I plus plus, and inside them is 4. Integer j it's equal 0 2. If j is minor, that root b dot length, here is roots, in the position root a dot length, and this is the same but with root b. J plus plus, and inside them basically I am checking the first with this element. This is one, because I want to do this inside them. If roots in the position root a in the position I, it's equal b in the position j, where r equal basically is we have a connection. It doesn't matter, I have, and I want to save this connection in where process map, yeah, here dot add, no, if contains I create process map dot put I, and is new hash set, yeah, and in this case the hash, even it's not necessarily a hash set, it's only necessary with one, because only save one value. It's only matters the one element, one connection between two between two roots. If, for example, is connected with or share exactly the same number of the stops, it doesn't matter. It's only necessary one. Yeah, and in this case, post map is this new hash. This, instead of this, is a simple integer. In here is yeah, even it's not necessary this boost stop mat dot put, and here I put j, the boost 0, no, road A is connected with the road B. If both are equal, the bus A is connected with the bus B, and okay, and in this moment I am transversing transversal this with this. I want to mix this function that help me to discover the connection and fusion with the or try to figure out if this root A or root B contains the source or the target. Yeah. But I think that is hard. In this case, roots this is minor, that would be in J. If this is minor, basically I++, else J++. Yeah. Now, in the case that happened, this basically is return for stop the process, or this stop this. No, I need to. If I find the connection, basically J is equal this. It's only for a stop. No, it should be works the return. The return should be stop this and continue with the next. I am having those here. Sorry. And yeah, I am traversing the route 1 with the next route. If I found the similar, yeah, I need a stop both. For this, I think that is enough. I need I it's equal the length and this, yeah, for a stop, and continue with the next. Now, right now I have the connection between both. No, if appear here, sorry, here is the buses map dot add, no, dot put, and in this case is the root A with the root B. I exist the connection, and here exists the connection is on the graph basically. Yeah, we have these connections. Now okay, right now I have the connection. Now the next step is discover where appear the bus source. In this case, bus source is this, and bus target. I need to, where are the source stops? Yeah, for this I need transversal again, all the routes in integer in root. Now this is stop. In here yeah, in here if stop is greater is greater that source, means that it's not possible to search after this point the source, because don't make sense, are sorted. Yeah, in this case return is only for stop the first fourth, this. And in the case that this is not true, I need ask if stop come on, stop it's equal source q dot add but here is using the buses. I need an integer bus it's equal 0 bus counter. Yeah, in this case is the 0. Is contained in this bus. Other case bus plus plus. Yeah, basically an essential is that if I have like this in the source it's equal to okay, here I for each this I take the first 1 is greater than source, no. 1 is equal 2, no. Okay, continue with the next. The next is 2 is greater than source, no. Stop it's equal to source, yeah, in this case is true. I add, and in this moment is return 2. No, it's not necessary because it's not possible to have duplicates here. Now with the next, this is greater, is stop it, yeah. And continue. Okay, now this is not necessary. Let me check if it works. No. Word failure here. Roads A. Is in singular, no plural. Yeah, I need to. It's a break, maybe. Okay. Now, in this moment, this is not necessary. And yeah, I need to check this. Sorry. Now here is I have the initial points. Yeah, I have the initial points of the source, and basically in essential is search in which moment reach the target. But for the target I need to do exactly the same, right? This but with the target. Okay, in this moment I am doing this way, but I need to convert as a function this code. Yeah, post counter, but here instead search the target, I am searching the post target. Yeah, and here is add post counter and is stop post counter. Oh, no, it's here. Target post counter. And now here is I am transversal, I mark as a visit. Now the next that is ask if post contain no post counter, no, it's not post counter, it's post target. If post target dot contains, this is in average, in the average is constant, contains the item return counter. In other case is a 4. Target and the bus map. Integer get or default bus map. No, but here is wrong. Yeah, it's only necessary one connection with another route, but I can have many single connection with different routes. Yeah, I need to come back this. And here is ask if post.mask contains key root A. New hash set. Yeah, here is the same but with the root B. Yeah, and here is only get add root B, and this is a positive. And now here, here, bosses get or the default its item, and the default is a new hash set. And here is ask if contains Sierra. Yeah, if it's not contained, q.add this. Map, where appear the map? Yeah, it's necessary this. Well, I am taking the first, I am taking the second. I think that with a simple if I should be minor math.max between this and this, but it's length. Another math.max between I and j should be minor than the max, where is greater equal is stop. What if math.max between I and j is greater equal that? No, this is mean. Why is still reaching? Plus 1. Yeah, I think that in this moment I need to stop this. Break and break. Plus 1, plus 1. It's only for be sure that I want to stop this. Yeah, sure, it's for this. Okay, now well, I think that I will continue in another session, but well, it's an interesting question. I think that I will try in a few weeks. I will try to solve again. But well, thanks for following this transmission, and I hope see you in the next. Bye bye.